Okay guys, so today we're going to do the molecular formula. If you've developed some pretty good skill on empirical formula, then molecular formula is really pretty much the same thing with one additional step, so it's not too difficult. Let's get started. So remember the relationship between the molecular formula and the empirical formula. So for example, so earlier we may have had a formula that was, say it was say that it was C2H6, and the empirical formula would be a reduction of that, CH3, a simplified form. So in the case of this, you divided out a 2 of each one. So that's to go from molecular formula to empirical formula. You divide out the common number. Well, if you want to go from the empirical formula back to the molecular formula, what do you have to do? Well, you have to multiply that same common number back in. So that's what we have to do. We have to find out what is that number and then multiply that number back in. And so that's what this little statement here basically says. So find this number that we divided out earlier and multiply it back in. So you need to find this number, which I'm representing here with an n, that we're going to multiply back in the empirical formula. The way to find n is, you can be taught this many different ways, but I just find it a real simple formula here, is n is equal to the molecular formula mass over the empirical formula mass. So the empirical formula mass will be, so for example, if we had our example we did a second ago, C2H6, which gets reduced down to CH3, the empirical formula mass is the molar mass of this, the empirical formula. The molecular formula mass is the molar mass of that. And if you divide the molar mass of this by this, you'll get 2, because 2 is the answer that comes out, that you divide out. And if you multiply that 2 back in to the C1, you get C2, and the H3, you get H6. So we need to find out what that number is, what that n is. So in our problems, the molecular formula mass is going to be given to you. This is going to be given to you in the problem. Somewhere it's going to state the compound has a molar mass of whatever. Laboratory, a machine would spit that number out for you, no problems at all. The empirical formula mass, you're just going to have to find the empirical formula and then add up the masses, just like you would any other formula mass. So let's get started on an example. You'll probably see two kinds of problems here, ones that are very simple and the ones that just take a little further. Simple ones are going to actually give you the empirical formula, like this one did. That tells you right here, the empirical formula is CH2. Right up here, you can see we have a molar mass of 28.0536. That's the molecular mass, the mass of the entire compound. And so to solve this out, you'll find out N equals the molar mass or molecular mass divided by the empirical mass. And so the problem tells you that the molecular mass is 28.0536 grams per mole. We just need to add up the mass of the CH2 and figure out what CH2 mass is. Hopefully you're starting to memorize these numbers. The carbon has a mass of 12.011. I'm just going to put 12 down. Hydrogen has a mass of 1.0079. That's 1 effectively times 2. So we get 12 plus 1 times 2 equals 14. When you're doing, when you're calculating molecular formulas, because your answer is always going to be a whole number over here, you can really round off your molar masses on your empirical formula. So 12 plus 2 is 14, and you can see right away 28 divided by 14 is going to give you what? It's going to give you 2. And so the N that we multiply back in is 2. Our empirical formula is CH2. We're going to multiply a 2 back in, if you will. It'd probably be actually better if we expressed it as that. Put that 2 out here. Distribute that 2 back in to the elements, and 1 carbon becomes 2 carbons, and 2 hydrogens becomes 4 hydrogens. And so our molecular formula is C2H4. So in this kind of problem, you'll be given the empirical formula, you'll be given the molecular mass. All you got to do is find the mass of the empirical formula and then multiply it back in. Second kind of example is just a little more of a complete one. where you don't have the empirical formula, you have to find the empirical formula. And since you know how to do that, it shouldn't be an issue. And so you're given percentages here of our compounds. And so let's go in and use our percentages to find our empirical formula. And so we'll do the mass to moles, divide by small, the whole little step here, divide small times till whole. Sequence. So since we have grams, we're going to make that assumption that we have 100 grams, and then therefore if we have 100 grams of carbon and 100 grams of the compound, and 40% is carbon, then we'll have 40 grams of carbon. We're going to have 6.6 grams hydrogen, and we're going to have 53.4 grams of oxygen. Let's do our mass to moles by using the molar mass. So 1 mole of carbon is 12.011 grams. 1 mole of hydrogen is 1.0079 grams, and 1 mole of oxygen is 15.999. Again, where do these numbers come from? They come from the periodic table. Hopefully you're memorizing these already. So hydrogen 1.008, carbon 12.001, oxygen 15.999. Like I say, hopefully some of these are sticking in your head. You're going to get here 3.33, 6.55, 3.34. When you divide by small, you're effectively going to get 1, 2, and 1. So your empirical formula is CH2O. This is 12 plus 2 plus 16 on your masses. So that's equal to 30. Your molar mass is 120. So 120 divided by 30 gives you 4. So you multiply 4 back into the CH2O, and you get C4H8O4. And that's how you do molecular formulas.